Good evening and a good new year to in and a. I'm Eric Walker, Chair of Highlands Astronomical Society, and it's my pleasure to welcome club members and especially all the new members who joined over the festive period, also visitors from our North of Scotland sister astronomy clubs, and to a whole raft of first-time visitors who have contacted us today wanting to hear this specific talk and to find out what we get up to at our monthly club meetings. The timings tonight are, I'll finish this in about 5 minutes. We'll then have our main talk, followed by questions and answers. At round about 8:30, we'll have club news, astro picks, and targets for the month presented by Pauline. And then just before 9ish, we'll wrap up and that'll take us to the meeting close. Just a wee reminder that, as usual, there won't be any breaks during the meeting. So if you need to leave for any reason, just get up and go and keep yourself connected to the meeting. Well, the weather has played havoc with our practical observing opportunities, and I personally haven't had a single one observing session over the past couple of months due to clouds or mist and one particular local light pollution activity I've got on the go. There are, however, often opportunities between 2 in the morning and sunrise, but not many folks will be keen to take that slot up, although we do have one extremely keen soul, David Davidson, who has managed to take quite a few photographs, which Pauline will show you later. Last time we talked, I was due to do some live observing webcasts with the National Astronomy Week team, and had it not been for an astronomer based in Cyprus, there would have been no live anything, I'm afraid. Notwithstanding, Highlands Astronomical Society has had a couple of achievements worthy of note. We, and when I say we, I really mean Lorraine Shepherd, our membership secretary, she has set up 2 WhatsApp group for members. The first one is Nebulous News, which informs members of astro events at short notice or as they are actually happening, for example, the Northern Lights, or of a live observing webcast being scheduled for that particular night, which we do hope we can do very soon. And the other group is called Cosmic Convos, where members can chat about anything astronomy related. If you missed the emails or you want to sign up to our WhatsApp groups, just get in touch with us, let us know. Now, I used the downtime in the last couple of months to build a computer-controlled all-sky camera, which is mounted on my house roof, and it webcasts live views of the sky 24/7. It's designed to show such things as constellations, meteors, bright satellites, northern lights, noctilucent clouds, star trails, time lapses, and it's already achieving quite a few of these things. That's a personal project and it's available for anyone to view, not just club members. Pauline might have details of how to view it in her presentation, but if she doesn't, I'm sure we can include the web link in the email we send out to people after this meeting. And finally, I'd like to thank Sigma for organising and delivering an excellent Christmas quiz, which turned out to be more difficult and certainly more competitive than I was led to believe. Great fun though, and fantastic to have different clubs from across the north of Scotland represented. And so, back to tonight's shindig. I'm going to introduce our main speaker for tonight, Stephen McIntosh. Stephen is a mathematician and astronomer living with his family in Inverness. He started off as a physics engine programmer in the computer games industry before embarking on a long career in life sciences as a senior research scientist and mathematical modeler. He now works freelance as an outreach astronomer and STEM educator, His passion for imparting knowledge of the cosmos and its mathematical underpinnings is infectious, to say the least. Some of you may already know Stephen in his role as astronomer, currently leading 2 outreach astronomy programs based at the Abriachan Forest Dark Sky Discovery Site above Loch Ness and the Merkinch Nature Reserve near Inverness under the umbrella of Highland Astronomy, where he delivers public outreach astronomy talks, tours, and private stargazing events at select dark sky locations around the Inverness area and wider Highlands. It's with great pleasure that I welcome Stephen here tonight, and here he is to talk about archaeoastronomy, one of my favourite topics, astronomy of ancient places. Over to you, Stephen.
By the way, thank you very much for inviting me. It's a great privilege to talk. I talked last year, and I really enjoyed being face-to-face with everyone. It's a pity that we have to do this online, but I've been really impressed by the organization of this so far. So here we go. So just a quick synopsis, first of all, about what I'll talk about tonight. Now, I did a talk previously on Facebook on the solstice, so there's going to be a wee bit of overlap if you heard that. I did that from my Facebook site. But then I want to kind of segue into talking about some specific structures, some in the British Isles, some close, Clava Cairns, for example. And if I get time, I want to go to ancient Egypt, talk a little bit about the pyramids. Again, depending on time, I'd like to do a little experiment perhaps with planetarium software just to kind of reinforce some of these ideas, particularly in the Egyptian segment. So let me just make some progress then. So thanks for that introduction, incidentally, Eric. That was very kind. And just to show you a couple of pictures, this is some of the work I do. This is up at Abriachan Star Stories. It's been running for a few years now. It's now supported in part by the STFC, but it's a very family-orientated program. We have lots of gatherings, stargazing, lots of binocular astronomy, not so much telescopic. And we also try to introduce kind of culture and storytelling. And we have Clellan too as our storyteller, and occasionally we have guest storytellers as well. So hopefully this gives you an idea of the kind of atmosphere of these events. They're quite special. And we're now doing these online. We've tried to introduce a wee bit of landscape astronomy into the program as well. So we've constructed a wooden henge, which I'll try to talk about a little bit further in the talk. You can go and visit that just now. It does need drained. It's not quite finished. And also I work in Inverness at for Merkinch. We've run this for a couple of years now, and this is at the Inverness Nature Reserve, which if you haven't visited it before, it's in the western tip of Inverness. You go to the North Keswick turning point, and it's kind of a hidden gem, I think, really. Not many people know about it. It is a little bit light polluted, but you can see the Milky Way if you go to the far end near the canal. But generally we run events and then we walk people up to the point and do a bit of stargazing if the weather permits. I also work for some hotels, sort of dark sky tourism, the Torridon over in the west coast of Scotland, which is very dark, and the Steadings. And occasionally I do some festival work as well, in amongst the other stuff that Eric mentioned. So let's get into the talk itself then. Now, I want to start this talk with a bit of a disclaimer. I think archaeoastronomy, unfortunately, there's a lot of nonsense, to kind of put it bluntly, that's written, published, and spread on the internet. And it's kind of a shame because there's real science and real discoveries to be made here, I think. And we just need to be very, very careful. And whatever I say tonight, you may be speculative, and that's great. And I'd like to encourage that, because a lot of the time periods we're talking about here. We just do not know. We don't have written records. But a few sites you might want to watch out for, megaliths.net, for example, which has some really good information on it, but then can occasionally jump to crazy claims. For example, here on the right, there's a claim that all the cairns in Scotland are linked to specific constellations. Now, again, difficult to disprove, but also incredibly hard to prove. There's also a famous one about the alignment of Orion's belt stars with the position of the pyramids, and I believe that's now been pretty thoroughly discounted. And also here is Nabta Playa, another claim about stone circles aligning with specific stars and constellations. On top of that, within the last few decades, there's been even more kind of outlandish claims made about possibly a wee bit bordering on the insulting as well. This idea that our ancient ancestors couldn't possibly have built all these wonderful buildings and monuments. So this idea of the alien architect has also sprung up. And even, Netflix shows like Outlander have, and again, I'm not criticizing these shows because they're great entertainment, but they've kind of all added to perhaps making this whole enterprise seem a little bit pseudoscientific, and it's probably scared a lot of serious research away. In fact, one of the main advocates, Clive Ruggles, who's the professor of archaeoastronomy at Leicester, he made a quote recently which said, "A field," that's archaeoastronomy, "with academic work of high quality at one end, but uncontrolled speculation bordering on lunacy at the other." So just bear that in mind. I'm sure you're all aware of it. And maybe if people continue to do solid work in this field, we can kind of demystify it. So with that, I'm going to now talk a little bit about the solstice. So the solstice, of course, not that far long ago, only a couple of weeks ago. So this is still apt, I feel. And this is trying to give us an idea of how our ancient ancestors would have viewed the sun and the seasons before we had calendars and clocks and all these modern aids. And the animation on the right, which I hope you can see, is showing the declination of the sun due south if you were to look in the same direction at the same time throughout the year. And what you will see, and this is incidentally is at Inverness latitude 57 degrees north, we see the sun in climbing, accelerating up to its highest point, and then it appears to pause, and then it goes through its downwards migration to the lowest point in the sky when we're in deep winter, and again it pauses, and then it turns around. And that is where the term solstice comes from, sol sistere, or sun standstill. And of course, with this changing declination of the midday sun, we get the pulse, the kind of throb of the seasons, if you like. This is a really nice animation, I think. Actually, I'm going to try to put my pointer on. Hopefully this is a bit clearer, showing you kind of ice and permafrost over a year at the North Pole. Now, another interesting artifact of focusing on the elevation of the midday sun, if you were to take a photo every couple of weeks at midday, you would actually trace out a figure of 8 called an analemma. And you could actually use an analemma as a seasonal calendar, something as simple as that. You could use to mark solar years. Now, you might think, well, how would our ancient ancestors have had access to this? Well, they don't have cameras. Well, you wouldn't need a camera. All you need to do is stick a stick or a rock in the ground, and if you go out at midday, when the sun's at its highest point, you can mark the position of the shadow at the back of that object. And if you mark that, you would also trace out this shape. And one of my favorite films, actually, Castaway, some of you may have seen it, has a really nice reference to the analemma when the main character is trying in desperation to plot his escape from this lonely island. There's a nice scene where he's marked off his months using some representation of this, which he's clearly produced using some object and the sun. So it's not just the altitude of the sun, though, that changes with the seasons. It's also the rising and setting position. And this is of great importance for some of what we're going to talk about later. So the idea that the sun rises in the east and sets in the west, well, that is only true at the equinoxes. And in fact, the sun changes its position. It swings from the south to the north. At the moment, we're deep in winter, the sun rises in the southeast, it sets towards the southwest. And the further north of the equator or south of the equator you live, the more extreme that shift appears. Now here's a nice animation that a guy in Germany produced. He had an east-facing flat, and I just love the raw nature of this. He just stuck a camera out his window, and every morning before he went to work, he took a picture just to plot this changing, rising position of the sun. And from this, we get the idea of a horizon calendar. So we've already talked about the analemma. You can use that to mark the solar year. You can also use the rising and setting positions of the sun to mark a year. And if you happen to live in an environment where there are lots of hills and topography that you can look at in relation to the sun, then you could use perhaps the notch of a hill, for example. This is Meeshau in Orkney, and this the sun setting here is correlated with the summer solstice in this case. But what if you don't have an environment where you've got hills and maybe you live in a flat area? Perhaps you're part of the Mayan civilization who had, tended to live in fairly flat, featureless jungle. Then perhaps you have the idea of artificially constructing something that will replace the horizon. And that's where we get the idea of a henge. And actually, this is a project that you could do with young ones, or you could even set up in your own garden. And it's quite easy. You could mark the summer sunset position when it rises and sets. And if you stand in the middle, you could draw a circle simply with a piece of twine or rope, and you've got a pretty decent circle there. If you have one person in the middle and one person walking around. If you run a line through these two vertices, you then get to the midwinter rising and setting positions. And then this way, you can kind of get to the idea of a henge. Here are the equinox markers also. And at right angles to those, you then have north and south. So getting back just to daylight in terms of the solstice, I just wanted to highlight here how extreme it is for us living in the north of Scotland. This shows the amount of daylight on the solstice if we go back a couple of weeks, and it was only 6 hours. But if we go to midsummer, we go all the way up to 18 hours of daylight. And of course, when you add in astronomical twilight and all these other effects, which are all defined by the extent of the sun's angle to the horizon, then in fact, we don't get darkness at all really this far north. And we are an example of people that live in quite extreme environment in terms of weather and seasonal shift. And the other thing to think about, which is interesting, is the speed at which this changes. Now, if you're in the dead, and this comes back to the whole idea of the sun standing still. If you go back to the end of December, every 5 days, the difference or the length of the day was only increasing by 5 minutes. But now we're into January. it will eventually go up to about 11 minutes. And then it accelerates as it goes into February and March towards the equinox. And you can see that from these curves. And if you remember a sine curve from your sort of school mathematics, that's a good way of thinking about this change. It doesn't appear to move at all at the top of the curves. And I guess that ties into this whole idea of the sun standing still. Look at somewhere like Nairobi, though, on the equator, where you get this really steady amount of daylight. And you get to then thinking about the culture shift between peoples who were in the equator and peoples who migrated north. And the weather and the changing seasons were a really big deal. Well, what drives the seasons? Now, I'm sure many of you know this, but it's worth reiterating because many people mistakenly believe that the eccentricity of the Earth's orbit is what drives seasonal change. But in fact, the difference there is only several million kilometers, and that is not enough to drive the seasonal change on Earth. In fact, if you want an example of a planet that is driven much more by eccentricity, then Mars is a good example. But the real reason that Earth has the great seasonal change it has is due to the obliquity, and Earth's angle of rotation is about 23.5 degrees to the ecliptic. And it's that's driving our seasonal change. So here is a nice animation, obviously not to scale. And we see that different hemispheres are lit more or less depending on the progression of the Earth around the sun. And I've just marked in some dates there. So at the moment we're over here and the northern hemisphere is inclined away. And you also get the equinoxes, which are the 2 points in the year when no part of the Earth is inclined towards the sun. And that's where equinox comes from. The word is equal night and day. And at that point, most of the Earth gets about 12 hours of daylight and 12 hours of darkness. And let's just tie this all together then. In a way, this is our experience of the dynamics of time. We live on a planet that orbits a star, that has an obliquity, that has a moon that orbits, that's driving tidal change. And I always think, in a way, that's my definition of ancient astronomy. It's the measurement of time and change using these bodies. I always think it's a nice thought experiment. What if you lived on a planet that was tidally locked with its host star, where the same face was the same part of the planet was facing the sun, for example? How would a civilization that evolved in such a place, how would they think about time? Potentially a question for the philosophers there, but interesting nonetheless. And just very quickly, obliquity is not something that's rare. It's very common to other planets. Mars, I mentioned, but it must be a very common thing in the wider galaxy for planetary systems around stars to have this off-center rotation. So weather changes like this must be pretty common out there. And just coming back to Mars, I just wanted to highlight how the eccentricity and the angle of rotation produce quite wild seasonal change on Mars. So at the point where Mars is furthest from the sun, its southern hemisphere is inclined away from the sun. And when it's nearest to the sun, the southern hemisphere is inclined towards. And what that means in terms of Mars is it gets a very extreme seasonal change on the southern hemisphere, but less so in the northern hemisphere. And again, these ideas might direct future colonies to possibly avoid the southern hemisphere, for example. But it's interesting to think about that. So just a very quick technical definition of the solstice now. The exact point in time when the North Pole is tilted furthest from the sun, which we've talked about. And I then want to kind of segue in this idea of where the sun is in relation to these events. Now, some of you may remember your old geography globes, and you may have noticed two lines of latitude, the Tropic of Capricorn and the Tropic of Cancer. Now, what do those mean? Well, during the winter solstice, the sun is directly over the Tropic of Capricorn. And of course, we know that Capricorn is a zodiacal constellation. And the reason for that naming was when the early maps were being produced, the sun was indeed in Capricorn at the point of the winter solstice in the northern hemisphere, and vice versa, it was in Cancer during the summer solstice. But that is not the case anymore. In fact, if you look at where the sun was on December 21st, it was in Sagittarius. So what's going on here? Well, the sun moves through each zodiacal constellation each month. Here's an animation to show you that. But there's another complexity to consider here, which is something called precession. The Earth does this giant wobble every 26,000 years. And that's due to the sun and the moon tugging on the tide, on the bulge at the equator. And as a result of that, all these zodiacal constellations have shifted out of sync. And it's one thing that astrologers are always disappointed to find out. Many don't realize this. But the other interesting fact is it changes the position of the pole star. So we are in our current epoch has Polaris, so named because it is the pole star. That's our current northern guide. But if you go back to any point in history or forward, you can get periods when there was no star towards the pole in the northern hemisphere at all. In fact, I was looking, I did a talk on the Neolithic a while back. We were talking about when our ancient ancestors first moved into the British Isles, when the last ice age retreated. And at that point, I believe the great globular cluster in Hercules was the object that the axis of the Earth was pointing to. And that makes you wonder, were our ancestors squinting up at this little fuzzy blob? Quite hard to see that globular, I think, naked eye, at least for me. I don't have brilliant eyesight. So, talked quite technically there about the solstice. Let's now try to talk a little bit more culturally about it. Why was it important? Well, if we think about our species, the human species Homo sapiens is millions of years old, but for a tiny fraction of our history, we've been living in this settled, sedentary style of life where we've growing food, we've got industrial farming and so on. For most of our history, we've tended to travel in groups. We've lived a nomadic existence. And therefore, it was very important to know when ice would melt so we could travel safely. We would be following migrating animals to hunt. And again, they would be driven by the seasons. And then when we moved into farming in the Neolithic, it became even more critical when you had larger groups of human beings living together, very dependent on harvest. If the timing was wrong, you could starve thousands of people. So that became a very big deal. Fertility as well. We take it for granted that we can conceive and have a child at any point now with modern medicine, but go back to these tough environments. And actually, you'd want to conceive at very specific points in time. And in Scandinavia, in Sweden, there is still a tradition of people dancing round the maypole. And the idea there is that you would conceive on the summer solstice, and then 9 months later, your child would be born in spring. And that would give the child a much better chance of survival. It wouldn't have to go through a harsh winter when it was in its very formative weeks after birth. There's also cultural and religious connotations to the solstice as well. And also, if you lived in the cold north, you wouldn't want to keep your cattle and feed them over winter, and it would tend to be the time when you would slaughter them, and therefore, contrary to what you might think, it was a time when there was an abundance of food. And we still, in terms of meat, that is, and we still see that today in Christmas when we have our Christmas dinner. It's kind of it carries on that tradition in a way. So just before we move on to the bit about monuments, I want to just try to set a little bit of atmosphere here. Let's try to cast our minds back and try to imagine maybe what people thought about the dead of winter. I know the weather's terrible just now. We can start to imagine how it would have felt. And again, if you had a society that was largely ignorant about astronomy, you might tend to think along these lines. And this is from a book called Handing Down the Old Ways. And I'm just going to quote it to you. Now, can I get rid of this? Yeah, I just had all the portraits on the right there. I've just minimized it. So at the winter solstice, we reach the depth of darkness with the longest night of the year. Darkness has reached its peak. Now we start to wonder, will this continue? Will the earth grow darker and colder as the sun disappears into the south until only darkness is left? But at Yule, a wonderful thing happens. The sun stops its decline, and for a few days it rises in about the same place. This is the crucial time, the cusp between events. The sun stands still, and everyone waits for the turning. In our heads, we know the light will return, but in the darkness of winter, can we be sure? Do our hearts believe what our heads tell us? Will the light keep its promises? We all have moments of darkness when we don't know how much deeper we will go before the light starts to return, or even if it will. The sun does start north again, and the light comes back. In the world, in our lives, the light comes back. This is indeed something worth celebrating, and it has been celebrated throughout the Northern Hemisphere in remarkably similar ways. And that leads me now into a look at ancient monuments. And if we just pause and think for a moment about what I've read, wouldn't it have been important for a community then, in the midst of the dark of winter, to perhaps mark this event, this turning of the sun? And what better way to do that than to build a giant edifice, something that people would look up to? You might think of an analogy in the huge churches that we construct. And there's no more grand structure than Stonehenge. And I just want to talk a little bit about that now. So Stonehenge dated to about 3000 BC. I'm sure many of you have visited it. I visited it a couple of years ago. I thought it was an amazing place. Now, there's a lot that's been written about Stonehenge that's very skeptical and dubious, but one thing that most experts agree with is that it was aligned with the solstices. And most people, when they visit Stonehenge, they go in midsummer. And if you go to the site in midsummer and stand in the middle of the site, and you look towards the northeast, you see the heel stone, which would originally have had a companion. And the sun does indeed rise on the solstice above the heel stone, marking that particular event. Now, what a lot of people don't realize is the evidence suggests that it was actually the other direction to the southwest that was more important for Stonehenge. And again, coming back to our idea, in midsummer, people are not so concerned. Things are growing. There's an abundance of food. There's probably less of a cultural need to mark the summer solstice. But again, in winter, that's when people probably needed that sense of community. And indeed, if you approach Stonehenge towards the southwest, which is the opposite direction, there is a great avenue that runs up to it, and the midwinter sun sets between these great trilithons. Now, I think I have a video I just want to share with you. Let me go back. And this was filmed, I believe, in the 60s by the BBC. And there you can see the midwinter sun setting between these giant structures. Quite an amazing sight. This is obviously very old footage, quite grainy. And one can imagine approaching the monument in a procession and marking this event. So there we go. That was just a very short video. And we do have evidence that Stonehenge was used for large gatherings. There's evidence of cauldrons and animal bones and so on. So I've played the video. And even if you go back to the early construction of the site, because Stonehenge actually started off quite a primitive structure with these pits and a trench, and it was always aligned towards the southeast. The avenue, the original approach, was in this direction, and it got built up over hundreds of years until it reached its culmination. And of course, we're still learning more and more about it. These Aubrey holes are quite interesting as well. Some astronomical claims have been made about those in relation to predicting eclipses and lunar standstills. I find some of that more difficult to swallow, but certainly I'm no expert on that, but there's a lot of interesting work done in the 60s on that. But you don't have to go to Wiltshire to experience some of these monuments. Scotland has many Neolithic structures that appear to be aligned to the solstice. This is Meeshow in Orkney. Again, I'm sure some of you have been here. It appears to be midwinter aligned. On the solstice, the sun will shine through the passage here and strike the back of the cairn. This is Newgrange in Ireland. This is similar, although it is aligned towards the southeast in midwinter, which is the midwinter sunrise. But perhaps even closer, and the Highland Astronomical Society are very privileged to be so close to this site, very close to Culloden battlefield. This is Clava Cairns. And it is a remarkable structure. It's not only a covered cairn, but it also has standing stones. So it's quite unique in that respect. But it has a southwest alignment on both cairns. This is a map of the site. When you come in the car park here and you first come across the northeast cairn, then there's a ring cairn of which there is a great mystery. There's still a lot being discovered about this structure. And the southwest cairn also has this alignment to the midwinter sun. And you'll also note that the stones increase in altitude, or in height rather, in that direction. And in fact, you see the same sort of phenomenon at Stonehenge. And this picture I took just shows you some of the stones here, and you can see how the stones are taller in this direction. Now, there's a guy called Douglas Scott, who's quite a bit of a local celebrity. I think perhaps he has some affiliation with Highland Astronomical Society. I'm sure he's mentioned you before, but I spoke to him about the cairns, and he took me around them. And he did a little experiment in the 90s, and he actually put a tarp over the northeast cairn just to prove that the sun actually does go down the passage, and he managed to take an image of it just to show that. And I think that's very important for archaeoastronomy, is not just to sit back with Google Earth and make claims. You have to go to the sites, I think, to prove some of the claims. And myself, a couple of years ago, I went with my family. It was a couple of days before the solstice, and we went down for about 3 p.m. We were just going out for a walk, and the sun was out, and it was a great opportunity. So I went into the northeastern passage, and there sure enough, the sun was beaming down the passage. And my daughter Violet, actually, I took an image of her standing at the back and the sun struck her. So that was a worthwhile trip. And I would encourage you to go to Clavicairns if you haven't been already. It's a great site to experience, not just for the potential link to astronomy. So I'm just doing a time check here. I've still got time. So that's me covered some of the monuments in the British Isles. So for the last part of my talk, I want to go to Egypt. Now, let me just check the itinerary here. How long have I got? I've got till 25 past. So what's fascinating about Egypt, I think, is you have these structures that were built in comparable time frames to the Neolithic structures we have in Scotland. But we actually had some written records, not quite going back to 3000 BC, but around about 2400 to 2600 BC. And we have a language or a script, which is hieroglyphs. And these were dubbed sacred texts. And I just find this fascinating that for such a long time, we did not understand or could not decipher these letters and symbols. And I think there's a lesson here. If we think about SETI, the hunt for extraterrestrials, which is a really honorable thing to do, but I always think if we are unable to translate our own people, our own ancestors' text within recent history, how difficult is it going to be to translate a message that you might receive from an extraterrestrial? So an interesting thought. But luckily, in 1799, this stone was discovered, the Rosetta Stone, by Jean Champollion, a Frenchman. As a young boy, he was absolutely obsessed with Egypt. He was a great friend of the mathematician Fourier. You may have heard of the Fourier transform. And apparently Fourier had loads of relics from Egypt in his study. And a young Champollion, as a boy, would just spend endless hours studying them, and he became absolutely obsessed. And therefore, when the Rosetta Stone was discovered, he set about attempting to translate it. And after not just work from him, but work from many academics, we were finally able to translate in 1822. And the stone, incidentally, had 3 different languages or written languages on it. It had the old hieroglyphs, it had Demotic, which was a kind of a more casual version of hieroglyphs, and then it had ancient Greek, and that was the key to unlocking this language. And from then, we had this ability to actually understand this very, very old culture. And we set about translating swathes of this stuff. And one really, really old set of notes was the pyramid texts. And this is apparently the oldest recorded kind of religious text in existence. These were hieroglyphs inscribed inside a series of tombs. And when these were translated, it was discovered that they were a kind of a guidebook for the Egyptian pharaohs. Now, when we talk about the pharaohs, we have to kind of think about them as a king figure, but not only in a political sense. The pharaohs believed that they were kind of half human, half god, and their role after death was to ascend to the outer world or to the stars. And the pyramid texts contain many references to this. After the pharaoh dies, it's almost like a Krypton factor type of challenge that the pharaoh then has. He has to go through doors, face sentinels, cast invocations, and so on. And the pyramid texts outline all these in a useful guidebook. So I want to now quote some elements of the pyramid text, and then I'm going to come back to the pyramids and try to make a bit of linkage here. So here's one quote. I will cross to that side on which are the imperishable stars, that I may be among them. Now, with this particular piece of text was inscribed the hieroglyph of the bull's leg, and that was what the ancient Egyptians knew as the plough or the dipper. And when we think about the imperishable stars, and hopefully I'm going to show you this with some planetarium software later, but what we believe they're talking about here is the stars that never set. And living in the north of Scotland, we have many circumpolar constellations, and that's what we think is implied by this. And of course, at the moment, Polaris is our pole star, and we can find Polaris using the dipper, which I'm sure many of you know already. And here's just an illustration of the imperishable stars, if you like, the circumpolar stars that never rise or set. So my second quote, you will regularly ascend with Orion from the eastern region of the sky. You will regularly descend with Orion into the western region of the sky. Your third is Sirius, pure of thrones. It is she who will guide both of you. And this is referring to the constellation Orion. And Orion and Sirius, incidentally. Now, let's talk about Sirius first. It was incredibly important to the Egyptian civilization. One of the reasons for that was when Sirius would first be sighted before the rising sun, that is to say, its heliacal rising, that would be about the time that the Nile Valley would flood and bring fertility to that region. So there was even a goddess assigned to this particular star. And in fact, if you go back to the genesis of the word Sirius, in ancient Greek, I believe it's scorching. And there was this belief that Sirius was like a second sun, and it was actually radiating energy and heat onto the earth. And this is the connection with Osiris, the god of the underworld, and Orion. Now, having said that, I'm now going to talk about the pyramids, and then we'll come back and make a connection at the end. These are the three great pyramids in Giza, incredible structures. And I want to talk about the biggest pyramid, which is the Pyramid of Khufu in the center. An incredible structure. This is how it would have looked like back in its heyday. White lime blocks used to adorn it. It would have looked absolutely stunning. It would have been capped with gold. So compare that to its dilapidated state now. And the construction of this artifact was quite incredible, the accuracy of its construction. So it was flat to within 15 millimeters. It had a side length error, or has a side length error indeed, less than 58 millimeters per side. And perhaps more importantly, it's very, very carefully aligned to north, south, east, west. And that's accurate to less than 0.1 of a degree. So here's an overview of the site, and you can see the three pyramids in a row, almost perfectly aligned cardinally. So here's north, here's south, and you'll note the Sphinx is facing east here, and it's off to the right. Now, why am I focusing in on the pyramid? Well, something interesting was discovered in the 50s and 60s, and that were these small shafts. Now, this is the picture from within the king's chamber, this fairly nondescript looking shaft. And there were two in the king's chamber and two in the queen's chamber. So I'm going to just show you that here. If you were to enter the Great Pyramid, you would enter in the north. You would go down a passage up into the king's chamber. And these two holes would be in the north and south walls. And they go off at very specific angles, and the same in the queen's chamber. Now, in 64, a very prominent astronomer, Virginia Trimble, she's still a very active. She's got something like 600 papers. She still studies the evolution of star systems now, but she used to dabble in archaeology back when she was younger. And Alex Baudry, who was an archaeologist, they wrote a paper in the 60s claiming that, in fact, these passages point to specific stars in the night sky. And indeed, if you measure the angle of the King's Chamber passage, it's about 31 degrees, and that is the latitude of Cairo. And if we think back to what we talked about in relation to the pole star, the pole star in Egypt would be 31 degrees above the horizon. And they also calculated that Kochab, which is a red giant star, it's called the guardian of the poles, it would have been aligned with the Queen's Chamber passage at its culmination. And similarly, if you go to the south, these passages would have been aligned with Sirius and the belt of Orion during culmination. Now, when I say aligned, I mean they would have been aligned back in the epoch when the pyramids were first constructed, because they are no longer aligned. Now, before I jump to the planetarian software, I just want to talk just briefly about the fact that Thuban, which was the old pole star, was called the immortal one. And these stars, Kochab and Mizar, were called the indestructibles. And again, indestructible because they're not setting is what we believe. And before I end then, I want to just demonstrate this with some planetarium software. Now, bear in mind, I'm not advocating this as an absolute truth. I'm merely trying to show you an interesting connection here to try to give you a flavor of some archaeoastronomy. Some people are convinced of this, some people less so. So how are we doing for time, incidentally? I've just gone over. I think you said I would be allowed another 5 minutes. So let me just finish this off. So this is Sky Safari. And I believe it's currently set at Inverness. So I just want to show you at the moment in our current epoch, if we advance time, our current pole star is Polaris, and there it is. And our circumpolar constellations include Ursa Major, doesn't include Bootes. Look at Bootes disappearing below the horizon there, but it includes Cephus and many others. Now let's stop this and let's go back in time to 2400 BC as a contrast. And let's now play time. And what we notice now is Polaris is no longer the pole star. But look at that, interesting. Bootes used to be a circumpolar constellation. So back when we were talking about Stonehenge and Clava Cairns, the northern night sky would have looked quite a bit different just due to this precession of the equinoxes. So I always find that fascinating to think about. But let's go now to Egypt, to Cairo. And we're now going to 31 degrees north. Now, I want to go to present time, which I have, I believe. There we go. And let's advance time. And what you'll note is that the Big Dipper currently is not a circumpolar constellation in Egypt. So let's watch it. Descends into the horizon. It's not an indestructible constellation, if you want to use that phraseology. But let's go back to the period of this paper that Trimble wrote, 2400 BC. And now the star Thuban is the pole star. Let me find it in Draco. There it is. It's actually quite a bit fainter than Polaris, this North Star, incidentally. I always struggle to find it when I'm doing outreach. But let's advance time now. And what you will note is that the plough or the dipper or the thigh of the bull, as the Egyptians would have it, is now a circumpolar constellation. And that is the precise alignments that have been claimed from the pyramid. So there you go. I'm just going to stop it there and go back to my slides. And thank you very much for listening. So I'll now stop sharing and hand back over to you guys.
Well, very good talk and very appropriate talk, Stephen. I've got a few questions.
Excellent.
One from Eric. I can see how the sun can be used as a calendar. How could our moon be used? Are there cultures where the moon was more important than the sun?
Yes, very good question. And yes, the moon could be used. In fact, if you go back to the word moon, if we think about the word month, originally in Old English, that was month. And in fact, if you go further back, the genesis of moon comes from me, which is to measure. And many of the old cultures had lunar calendars. And in fact, there is still some remnants of that in the Islamic culture, in Chinese culture, and even bits of Eastern Europe, actually. The religious calendars still use lunations. The problem always was that you could never fit an integer number of lunations in a year. So you always had to jump around and make corrections for it. So that's the immediate question about the moon. In terms of the long cycles of the moon, though, there's also the major lunar standstills, which I believe are up to an 18-year cycle, which can predict eclipses. Now, some people claim that some of these structures are aligned with standstills. I'm less convinced about that, but that's just my impression. Did these civilizations know about that? I'm not sure.
Thank you very much. From Martin, this is, do you know any links between astronomy and the many cups and ring marked stones in Scotland?
I don't, Martin, but I was speaking about Douglas Scott. He's obsessed with these cups and rings. His idea about the cups and rings is that people would have ceremonially ground a stone or an object into these large stones as some way of connecting themselves with ancient ancestors, potentially. I don't know of any particular mathematical alignment with these cups. Again, I'm not a massive expert in this field, but and a lot of it's speculation. What I've heard with clava, though, is the understanding is potentially the alignment isn't really astronomical, but it's more of a symbolic, cultural, religious thing. So perhaps the solstice was seen as a time when the sun would perhaps bring back the dead or something. And we see some of that in Celtic civilizations and mythologies as well.
This one is from me. You mentioned Stonehenge, but the equally famous one is the Canis stones.
Yes.
And are they aligned at all?
So our current understanding is Canis is not aligned to the solstices, but some people claim it is aligned with the equinoxes. Of course, it's very easy to find alignments to the equinox. This is where I always struggle a little bit, is you can take 2 points, you can draw a line. There's also some claims about the lunar standstills at Canis, but as far as I know, I don't think that is solstice aligned as such.
Right, there's one from Eric. This is a very local one. Conan Bridge Henge. Is thought to date from the 2nd to 3rd millennium BC. The locals call it the Druid Circle. Is that anything to do with archaeoastronomy?
Yes. Again, there is apparently, I believe that a particular cairn faces south. And again, I'm going to quote Douglas Scott here again, because I was speaking to him recently about this. And he believes that particular structure is aligned to the major and minor standstills of the moon. But yeah, I don't know as much about that. but definitely worth visiting. And there's actually dozens of these cairns around in various states of decay. I believe the Calava style cairns, there's about 50, 60. And there's also Orcadian cairns that number in up to 100, I believe. There's still loads of work that could be done here. Yeah.
Well, thank you very much.
Well, Rona, can I thank you for handling the question and answer session tonight? Some fascinating questions there, and I know there was 2 or 3 you didn't get a chance to ask. Just like to take this opportunity to thank you, Stephen, for a most interesting and thought-provoking talk. It certainly makes you think about the local area that you live in and how the ancients strove to use their knowledge and experience of nature and life to interpret and predict events that were important to them. Now, in pre-COVID times, Stephen, you would be physically receiving a token of our appreciation and a thank you card designed and printed by Pauline. You're still going to get them, except we'll need to send them to you in the old-fashioned way, especially right at this moment. So, Stephen, thank you very much once again, and I hope you can stay with us for a wee while anyway and experience the rest of our club meeting. You're in for a treat. And now to the club news, astro picks and targets for the month. Pauline is with us again to show you what the club has been getting up to. She has some stunning photographs taken by us enthusiastic amateurs, and she also has what we should be looking out for in the winter night sky. Pauline.
Thank you very much, Eric. Okay, so tonight we're going to have a look at a couple of winter shapes and a unicorn. In just the same way as the summer has a summer triangle, the winter has a winter triangle, but there's also a larger asterism, which is known as the winter hexagon or the winter circle, which includes and surrounds the winter triangle. Now, if you look south during the months of January to March in particular, the winter hexagon plus triangle is really very visible. You can also see it in December, but you need to stay up a little bit later because you have to wait until Sirius rises. So the winter triangle is made up of 3 very bright stars in our night sky. We've got Sirius, Procyon, and Betelgeuse. Sirius is the brightest star in Canis Major. This is the great dog. But the lower half of the constellation itself can be a little bit tricky to see at our northerly latitudes. You really need a clear southern horizon. Sirius isn't just the brightest star in Canis Major, it's actually the brightest star in our sky at magnitude minus 1.46. Now, it's an ordinary white star, but it's only 8.6 light years away. So this is one of our closest stars, not the closest, but one of our closest stars. And this is why it's as bright as it is. It has a faint white dwarf companion too. Procyon is in Canis Minor, or the little dog, a very easy constellation because it consists just of 2 stars here. And Procyon is very similar to Sirius. It's also a white star. It's also bright, although not quite as bright as Sirius, and it's just 11 light years away. So again, it's a close star. And strangely, it also has a faint white dwarf companion. And then we have Betelgeuse, forming the left shoulder of Orion. It's a variable star, but when it's at its brightest, it's as bright as Procyon. But look at the distance. It's hundreds of light years away compared with Procyon and Sirius. So how can it be as bright as Procyon? Well, that's because it's a red supergiant star. And if it replaced our sun in our solar system, it would be as large as Jupiter's orbit. And because it's such a large star, it's incredibly bright. And that's why we see it as bright as we do. In the center of the winter triangle, there is a faint constellation called Monocerotis. which is the unicorn. Now the stars only have magnitudes between 3.9 and 5, so it's very tricky to see. And even if you have a dark sky sight, it's still difficult to see because there are so many stars in a dark sky that trying to pick out the slightly brighter ones is rather difficult. However, it is one of our 88 constellations. So if you've ever wondered where Monocerotis happens to be, then the winter triangle acts as a really good signpost. Now, fortunately, or perhaps not, well, yes, quite fortunately, it lies within the Milky Way and therefore has a number of deep sky objects, particularly star clusters. And for instance, we've got a Messier object here, which is the only Messier object in Monocerotis. And this is quite a nice bright star cluster, easily visible in binoculars. In fact, probably, you know, your best bet is just to do a little bit of scanning with your binoculars within the winter triangle to see what you can see. And some of the star clusters are definitely brighter than others. NGC 2301 is actually quite distinctive with this long vertical train. 2232 is a very small cluster, but it does have a magnitude 5.1 star within it. And therefore you can pick that out in binoculars quite nicely. And then 2506 has a lot of stars in it. It's quite compact, but it's very far away. But perhaps the best known object within Monocerotis is the Rosetti Nebula. And this is an absolutely stunning nebula. Unfortunately, it's very difficult to actually see with a telescope, and you need long exposure photographs in order to bring out all the nebulosity. Although apparently from a very dark sky sight, if you use binoculars, you should just be able to make out the outline. But what you will see is the open star cluster in the center, and it's shaped like a rectangle, so that makes it easy to see. But the other amazing thing is these stars were formed from this cloud of gas and dust, because this is a starburst region and it's still producing stars today. And then we have 2264. This is the Cone Nebula, but also the Christmas tree cluster. Now, unfortunately, seeing the Cone Nebula and seeing any of the nebulosity is really difficult, even with a telescope. And once again, you need long exposure photography to be able to see it. But what you will see is this upside down Christmas tree shape. So what I've done is to find a black and white photograph, turned it upside down, and now you can see the Christmas tree shape really quite nicely. So that's worth looking for. And then the only other object I'm going to mention is V838 Monocerotis. And I spoke about this particular object in my talk back in February last year, because this was an obscure star until around 2002 or so, when it suddenly brightened and became the brightest object in the galaxy. It was 1,000,000 times brighter than our sun. And the reason it did this, they think, is because it swallowed a star and then burped. As it is, it's now reduced in brightness. You will not see it even with a large telescope because it's only, well, it's almost magnitude 16. So it's far too faint now. But in case you wondered where it was, because you'll see plenty of photographs of this around, now you know. This is a photograph by Gordon Mackey of Canis Astronomy Group, and he's very kindly given me permission to use it because it shows the winter hexagon really beautifully here. And the great thing about both the triangle and the hexagon is that it's a brilliant way of learning 6 constellations and 7 stars. Now, it could be a hexagon because of the 6 constellations, but most of us use 7 stars, not 6 stars. Very often people will miss out Miser here. So let's have a look at the triangle. We know this one, Sirius, Procyon, and Betelgeuse. But if we have a look at the hexagon, which takes in the two of the stars of Gemini, you'll find now that Betelgeuse is close to the center. So we have Sirius, Procyon, and then we've got Pollux and Castor, both within the constellation of Gemini. That's his little foot, and then we go up here. The really good thing about this photograph is the way it's done, it brings out the colors. So we can see that Pollux is slightly orange. It's an orange giant star, good brightness. And just take a note of how far away these stars are. Castor is a blue-white star, and its magnitude is a little fainter. And if we go up to Capella, this is a yellow giant star, and it's situated in Auriga, which you can see here. Now, just going back to Castor and Pollux, I always get these two mixed up, which way round they go. And so the best thing to do, well, this is the way I do it, is to take the initial letter of Procyon and Pollux, and you've got PP, and then the initial letters of Castor and Capella, and you have CC. So that's the way to remember it. So again, just take note of the distance both Capella and Aldebaran are. So now we go down to Aldebaran, which is known as the Eye of the Bull. And it looks as though it's part of the Hyades, which is this triangular open star cluster here. Unfortunately, I've plonked the name of Aldebaran right on top of it. But Aldebaran itself is not part of the Hyades star cluster. It's a foreground star, so it's quite separate. And if we go from the edge of the bottom part of the triangle here, the open part of the Hyades star cluster, and move along to this star, this is one of the horns, and just above it is M1, the Crab Nebula. And if you go to the other part of the triangular part of the Hyades and move upwards, you come to the other part, the other horn, the end of the other horn. Only this star is shared with Auriga. And here are the Pleiades. Now go from Aldebaran all the way down and you'll come to Rigel, which is the right-hand knee of Orion. Now look at the distance Rigel is from us and compare it to the distances of all these other bright stars that we've looked at. So just like Betelgeuse, it's extremely bright and yet hundreds of light years away. And this is because it's a blue-white supergiant. So it's not as big as Betelgeuse, but it's incredibly hot. And it is big, but not, as I said, not as big as Betelgeuse. But because it's so hot, it's incredibly luminous. And that's why we can see it as brightly as we do. So if we go on to what we can see in the night sky, this is a sky map for January, around 8 o'clock in the evening. And here is our winter hexagon, quite nicely there. We are losing all our planets, unfortunately. Jupiter and Saturn are setting in the southwest, and by the end of January, they will have fallen into the sun. I can see that Gordon Gallagher saw the conjunction on the 21st, and I know that Barbara also saw the conjunction on the 21st. It was cloudy for a lot of us, but if anyone else did see the conjunction, write it in the chat box, and then Rona can see how many people actually did see the conjunction on the 21st. And then we have Mercury that's poking his head up above the horizon, but it doesn't get very far. 10 degrees when it's at its furthest point from the sun on the 24th of January. This would make a lovely photograph, but you would need a very clear southwestern horizon. Venus, meanwhile, is still bright, but once again, it's sinking into the sun. Only this time we're going towards the rising sun. Now we've got nice crescent moon And this is a lovely photo opportunity, which is the sort of photograph that Dave likes to take. And this would be 1 hour before sunrise. So that's pretty early in the morning. Mars, fortunately, is still visible. It's getting fainter, it's getting smaller, and it will, unfortunately, start setting at around 11 o'clock or so at night. January the 21st, Uranus is very close to Mars. Unfortunately, seeing it will be quite tricky because of a gibbous moon, and the full moon occurs on the 28th of January. Now, this is a heads up, something to look forward to. We have a partial solar eclipse in June, a partial lunar eclipse in November. Well, I'm also going to say thank you for to Sigma for organizing the quiz. We did have a fantastic time. This was a screenshot taken by Eric just to show what a fantastic evening it was. There were more than 47 participants because there were 3 of these pages. And hopefully we can do it again with all the clubs. And Eric's already spoken to you about his all-sky camera. And these are the photographs he sent me. And I am not going to ask how he managed to get it onto the roof. The fact we've seen him tonight suggests that he did manage to get back down safely, thankfully. And this is the sort of photograph that he can take. Now, you've already seen a photograph like this by Stephen. These are star trails, and there is Polaris, because of course everything rotates around Polaris. This thick line here is Mars. And you'll notice that this is north, because it's closest to Polaris. We've got east, west, and south. This is the website, and I will put it into Stargazy Pi so you'll all know the website. This is a different view of the all-sky camera, and I'm showing you this one. You can't see the stars properly because this is a view of the moon with a nice ring around it. But it's got, this photograph shows the menu, and if you click on the zigzag, which I think is Cassiopeia, then it overlays the image with a sky map, and you can identify the constellations. Eric's also mentioned the WhatsApp group called Nebulous News. That's the one you use to inform members of things like the aurora. You need WhatsApp installed. Just be aware your telephone number will be visible to everyone. Thank you very much to Lorraine. And then there is the chat group where you can just write anything you want, questions or observations, etc. So this is there will be a few talks about geology of other planets, in other words, not the Earth. So they will be available both live and recorded on the Geological Society YouTube channel. The first one is going to be Wednesday the 10th of February, and that just looks like an introductory one. They can be booked and they are free. So thank you, Rona, for that. And now we have all your wonderful photographs. We have got a lot of photographs, including many moon pictures. So I'm just going to go through them bit one by one. The first one's by Eric. This is Grimaldi, and this is this one. I'm not going to try and pronounce it. These are brilliant photographs. And then we have some by Dave. And again, you've got Copernicus here. There it is. Mare Imbrium once more. Sea of Serenity. And I love Dave's really thin crescent moon. So this would be just past new moon. And another crescent moon. Beautiful. Now this is the full moon on the 30th, and a couple of days after that, you can already see the edge gradually disappearing, but it throws all of this side into sharp relief. And this is Mare Crisium. And already you can see the edges of the craters, which is why it's always good to look at the moon once it's past full moon. And I thought this was quite photogenic. So we're on to some of the planets now. So Dave has photographed Jupiter with the Galilean moons here, and we've got the nice banding features of Jupiter. We have Saturn, which is an amazing photograph, Dave, well done. This was my attempt through my telescope, but Saturn does look slightly elongated and Jupiter is virtually round, so I was quite pleased with that one. Now, Sue Shackleton of North Ronaldsay Astronomy Group, and I must say congratulations to Sue, because I think a couple of her photographs were shown during National Astronomy Week, so that was really good going. So here we have Jupiter-Saturn conjunction on the 16th of December, and remember how far apart these two planets are. This is a close-up, and you can actually see the Galilean moons of Jupiter, and her Saturn is nicely elongated too. This is a beautiful ethereal photograph by Mick O'Donnell. With the crescent moon, you can just see the Earth shine. And the conjunction, this is the 17th of December. Once again, Gordon has also managed to get Earth shine. Beautiful atmospheric photograph. Again, the 17th. Dave has managed to capture the moon and the conjunction on the 17th and the 18th. And Charles Tate from Orkney, a newcomer to our photographic section. And this was taken on the 18th and with the conjunction. Again, a beautiful photograph. Mick has taken this, I presume, through your telescope. We've got a nice elongated bit to Saturn. Is that Titan? And then we have Jupiter with some of the Galilean moons. Same with Pete. This is on the 19th of December. This is a magnified image from Dave. And you can see this cloud was a real pest on the 20th because it kept covering up both Jupiter and Saturn. This is a photograph by Paul, 12 miles from Tongue, and he obviously had really nice skies on the 20th. But remember the one that Sue took on the 16th, and you can see how close Saturn has got to Jupiter the day before, the time when they were closest together. And then we have another photograph by Sue on the 20th, which is really nicely arranged and very appropriate for our talk tonight from Stephen. And this is a magnified image of Saturn. And in order to get Saturn, you have to overexpose the image. So this is why Jupiter looks as though it's swimming in the atmosphere here. Now, we're on to a few photographs of the deep sky, the sky camera. And you can see the meteor here. And this is the 12th of December when we have the meteor, the Gemini meteor shower. So Eric has circled Gemini and put in a line to show that this is where the meteor, the direction it came from. So it's most likely a Geminid. Now, whether this one is a Geminid or not, I don't know. Here is Gemini right over here, so it could just be a sporadic. This is Auriga with Capella. Here are the Pleiades. We've got Cassiopeia. You can see the Milky Way moving up through the sky here. This is the square of Pegasus, and if we count 1, 2, and then up 1, 2, there is M31, or the Andromeda Galaxy. So you can see this is a really good way to learn the constellations and where they are in the sky. And here we have what looks like a fireball, or a boloid, as Arthur would call it. And as star trails with, and I presume this is the satellite CosmoSat-Med 2. We've got a few photographs of Mars taken on the 6th of November, before Mars got too faint and too small. And the detail is beautiful. This is a photograph by Alan from Sigma. You can see the polar ice cap, and I think what he's done is just to turn this round or upside down, because the detail is the same on both images. Absolutely amazing. And Dave entitled this Mars Canals because there are some dark streaks on this particular image. And yes, the sun did actually come out for a short while, certainly in November. Anyway, we have this wonderful sunspot group. That was from Dave. And then this is an image from Eric, which I'm assuming is with your Hydrogen Alpha telescope. And then on the 25th of November, we have this huge sunspot. 3 days later, we have the sunspot again with a few other smaller sunspots, as well as this one. Now, the sunspot hasn't just gone up vertically, it's just the way the photograph has been taken. Otherwise, it would still be in this almost horizontal position. A few deep sky objects from Dave. This is the Great Orion Nebula. I want you to have a look at this little indentation here, and there are 3 stars across here. And this is what you can see in this image here. There are the 3 stars, and that is the indentation. So it's not quite, or it's not exposed as much as the previous photograph, so that you can see this. This is my favorite photograph. This is the Sombrero Galaxy. You can actually see the dust lane right through the center, which is what gives it its name. And then close on the heels of that one are, of course, these beautiful aurora photographs. This is by Dennis from Tain, and this was on the 21st of November. And then same evening, Sue Shackleton from North Ronaldsay also captured a couple of gorgeous images of the aurora. And we have a very unusual phenomena here, phenomenon. These are ice crystals or ice pillars, and they are due to light reflecting off ice crystals in the sky. So this is really rare, and it shows just how cold it must have been that night. And this looks like a satellite trail. And then another favorite of mine, the moonbow. I think Sue knows that I love these moonbows. But whether it's a moonbow or a rainbow, and of course a rainbow is also called, well, it's caused by our local star. I always think of moonbows, rainbows as symbols of hope, light at the end of the tunnel. So although we've had to lock down again, don't forget to look up, because there's plenty to see in the sky, and we will get through this once more. Thank you very much for your wonderful photographs, everybody. Absolutely brilliant.
Pauline, thanks very much for that. That was fantastic. What splendid targets you've given us to aim for. And I'm never now going to be able to look at that object without thinking it's swallowed a star, then burped. My goodness me. I've got a picture of that face in my head. All those beautiful astrophotographs, they're amazing. Considering the poor observing weather we've had for so long, we've obviously got some very, very keen enthusiasts in our astronomy clubs across the north of Scotland. So thank you, Pauline.
Thank you very much.
Excellent. Well, guys, I think that is just about it for tonight. I'd like to take the opportunity to let visitors know that you can currently join our astronomy club for the next 3 months for a mere £8 per adult, or £13 per household, £1 for a junior, or £2.50 for a full-time student, or if you're unemployed. all our meetings for the next 3 months, well, probably the next 5 months or so, it's all going to be done by Zoom and webcaster observing sessions. But I can at last see the time in the not too distant future when we're all back together having a chat and a laugh. If you're interested in joining our club, just get in touch with us by email, website, Facebook, or Messenger, and we'll get things moving along for you. Thanks once again for coming along. I hope you've enjoyed yourselves. Clear skies and keep looking up.